Okay, here are the supplemental 7.4 notes. These are rational equations, or solving rational equations is really what we're focusing on. First thing, this might be a good time to pause the recording, do the 3 problems in the warm-up, and just make sure you remember how to do some of the foundational stuff. So, welcome back. A, we want to factor x squared minus 36. X squared is a perfect square, 36 is a perfect square. This is a difference of 2 squares, which always factors the same way. The square root of the first minus the square root of the second times the square root of the first plus the square root of the second. And it really doesn't matter what order we have those in. But just in case that didn't come easy, if you don't remember that, especially if you're going into calculus, really important to understand difference of 2 squares and how it looks, because you will find that you get a lot of things that you can factor or treat as a difference of 2 squares, even if they aren't as nice and neat as this one. Okay. Second one asks you to solve for y, which means we want to get y by itself. We're going to start by getting rid of the 5x. I cannot combine the 10 and the 5x. 10 is a constant. The 5x has a variable part. And then, because we want 1x and not 2x, we're going to divide everything by 2. And we get y equals 5 minus 5 halves x. Typically okay if you leave it as 10 minus 5x all over 2. Sometimes if it looks like it's the equation of a line, we want a slope and an intercept. Last one, 1/3 plus 2/5. Because we are working with rational functions, it's important that we remember how to work with rational numbers. So before we can combine anything that's a fraction, we got to make sure that everything is in same size pieces. And when I say pieces, I mean the denominator. Because that first fraction, 1/3, means that I have one chunk of size 1/3. 2/5 means I have 2 of the pieces that are size 1/5. When we multiply fractions, we multiply straight across. No stinking butterfly method or whatever mnemonic you were taught, whatever little trick. No. Multiply fractions straight across. Okay. Next part, we want to make sure we know the difference between a rational expression. A rational expression is something that has got a rational number in it, or a fraction. Typically, when we call it rational, we've got an x in the denominator. We're not going to get that picky right now. We are talking rational equation when we have the equal. So it's this equal part that makes it an equation. Okay. Now, the first 2 pages of these notes walk you through the examples. I am going to point out a couple of other things. Okay. So this first example here, I've got 1 over x plus 1 over 3 equals 5 over 6. Notice, first thing they tell us is that x cannot be 0. If x is 0, then I would have 1 divided by 0 right here in this first expression. We know we can't ever divide by 0, so if by some chance we get a 0 as a solution, we are just going to cross that out and ignore it. Okay. Second thing we're doing is finding the least common denominator. Now, some people are more comfortable with fractions than others, so I just want to point something out. So I'm going to write this up here. 1 over x plus 1/3 equals 5/6. I cannot solve for x while it's in the denominator, but I can multiply everything by x. As long as I multiply everything on both sides, I have not changed the value. Okay, and I have not changed my solutions. Why would I do this? If I multiply everything by x, this x over x cancels and I just get 1. Okay, so now my x is no longer in the denominator. Now I'm going to pick the biggest denominator, 6. I'm going to multiply everything by 6. The 6 and 6 cancel here. That was kind of the point of that. 6 here cancels with the 3, so that knocks off that one. Now I have 6 times 1, which is 6, plus 2 times x, so 2x, equals 5x. Here I now just have a standard equation and one variable. I have variables on the both sides. And so we're going to come on down here. We're going to subtract the 2x from each side. Notice here it got flipped around. 6 equals 3x is the same as 3x equals 6. And then we're dividing both sides by 3 to get a solution of x equals 2. And now, we can always plug these back in and check. To make sure our answer is correct, and we definitely want to check to make sure it does not give us a 0 in the denominator. All right. So just for fun here, we are going to take our x equal 2 solution. I got 1/2 plus 1/3. I want to see if that equals 5/6. If I get a common denominator, I'm multiplying this fraction by 3 over 3. 3 over 3 is just a different way to write a 1. So I'm not changing the value of the fraction when I do that. I got to multiply by 2 over here. So I get 3 over 6 plus 2 over 6. Again, common denominator stays the same. I've got 3 pieces of size 1/6. I've got 2 more pieces of size 1/6. That gives me 5 pieces of size 1/6 or 5/6. Okay. Next example. Here, notice that I have got x's in all of the denominators. So I start by factoring whatever I can. Okay. So there really only are 2 separate linear factors, x minus 1 and x plus 1. So if you take a look at this line right here, we multiply everything by x minus 1 times x plus 1. Here, my x minus 1's cancel. Remember, all of these over here can be written as a fraction over 1. We tend to leave that part out. It doesn't really change anything, but always good to have the reminder. My x plus 1's cancel here. And then over on this side, both my x minus 1 and my x plus 1 cancels. If you take a look at the next row down, we've got what's left. X plus 1 times negative 4x plus x minus 1 times 4 equals negative 8. So we are going to go ahead and solve this. I'm multiplying through by negative 4x. I got a plus 4x minus 4 equals negative 8. I am going to move everything to the same side. I I got negative 4x plus 4x, that zeroes out. I got plus 4 when I move the 8 over. I'm going to factor out the negative 4. So I get x squared minus 1. When I factor that, I get x minus 1 times x plus 1, which means x equals 1 or x equals negative 1. And here there's a problem. Because if I go back up to my original equation, right up here, and I go to plug in x equals 1, I'm going to have a problem with this. That's going to give me a 0. This other side is also going to give me a 0. So I look at x equals negative 1, and that's going to give me a 0 in the denominator right here. So neither of these work, and we have no solutions. Last example we're going to look at is solving a literal equation. So we're going to take a rational equation where you're going to solve for a specific variable. And in this first example here, we want to solve for y, which means the first thing we're going to get rid of is this x minus 3 in the denominator. I got to get y by itself. I got to get this denominator gone. Okay? So we multiply both sides by x minus 3, because whatever I do to one side of an equation, I have to do to the other to make sure it stays equal. The x minus 3's cancel over here on the right-hand side. Notice that the m is distributed over here. We go ahead and add 2 to both sides. And we have an equation for y in terms of x and m. So if we had an x value and the slope, we could solve for the y that goes with that x. In the meantime, we're going to leave that written as a function in other variables.